This is how you can tell if this is going to be a linear function or not a linear function. And keep in mind, a linear function means that if you were to graph this, it would be a straight line. So let me show you how to figure it out first without graphing. So what I'm going to do is I'm going to look at the x values. And don't forget, these are all ordered pairs. So these are my x values here. Is the first number in each of those ordered pairs. And what we're going to do is we're going to check, does it have a constant rate of change? Which means this. If I check from this x value to this x value, I can see that it increased by 1, right? -1 plus 1 is 0. And then I keep checking each one again. So from this x value to this x value, it increased by 1 also, right? 0 plus 1 is 1. And then from this x value to this x value, again, it increased by 1, right? Because 1 plus 1 is 2. So we have what we call a constant rate of change, meaning this number is the same, is increasing by the same amount every time. And now all we got to do is check the y values. So the y values are going to be the second value in each of these ordered pairs. So it's the second number for each ordered pair. And we're going to check, okay, from this y value to this y value, you can see it went from 0 to -4, which means it decreased by 4. Now from this y value to this y value, you can see it went from -4 to 0, so it increased by 4. And then from this y value to this y value, you can see it went from 0 to 4, so it increased by 4 again. Now notice that in two cases it increased by 4, and in this case it actually went down by 4. So this does not have a constant rate of change for the y values. Meaning if you look at these numbers, it did not change by the same amount every time. In this case it went down 4, then it went up 4 and up 4. To have a constant rate of change, it should be the same in each case like we had for the x's. And since we don't have a constant rate of change, meaning it doesn't change by the same amount every time, this is not a linear function. And let me show you a quick sketch of what this looks like if you were to graph it. So draw a quick sketch, xy axis. We have to plot the point -1, 0, 0, -4, 1, 0, and then 2, 4. So I'm going to plot those points. So you can see, look, -1, 0 would be right here. 0, -4 would be right here. 1, 0 would be right here. And then 2, 4 would be right here. So if you notice, if I were to connect these dots, there's no straight line can pass through all these points. This is why it's not a linear function. So linear function means we're looking for this, a line. So you can see the keyword is built into the word linear. Linear means that the relationship should be a line, a straight line. And you can see here it's not. So this is not a linear function. And again, without a graph, that's how you can tell, is by looking at the changes for the x values and the changes for the y values. And as long as it's the same for both, for the x's and the same for the y's, it'll be a linear function. But you can see here it wasn't the same. That's why this is not a linear function.